Bismillah, Alhamdulillah, Wassalatu Wassalamu ala Rasulillah. These are some review exercises about chapter 4. The first exercise, find the local and absolute extreme values of the function on the given interval. To find the local extreme values, we find the derivative and we use the first derivative test or the second derivative test. To find the absolute extreme values in a given interval like this, we put the endpoints of the interval and the critical numbers in a table, and we find the absolute extreme values. So the first step is to find f prime, and let us find f prime of x. 3x squared minus 18x plus 24. And to solve this equation, to find the critical numbers, we put this equation equals the derivative, the first derivative equals to 0, and we solve for x. If we divide by 3, we can divide by 3 because it's equal to 0. X squared minus 6x plus 8 equals to 0. And then I can factor easily. X minus 2 times x minus 4 is equal to 0. So either x is 2 or x is 4. So these are the critical numbers. Now to find out which one of them is of these two critical numbers is local maximum or local minimum, I can use the first derivative test or the second derivative test. Well, I'll find the second derivative because it's easy to find here. It is 6x minus 18. And then by finding f double prime of 2, it's 12 minus 18, that's less than 0. So I have a local maximum at f of 2. So the local maximum is f of 2. And when I replace, when I find f double prime of 4, it would be 24 minus 18, and that's greater than 0. So I'll have a local minimum at 4. So the local minimum is f of 4. So the local maximum is f of 2, and the local minimum is f of 4. Now to find the absolute maximum and the absolute minimum, I make a table for x and f of x. I put the endpoints of the interval 0 and 5, so I have 0 and 5, and the two critical numbers are 2 and 4. And notice that 2 and 4 are in the interval from 0 to 5, okay? And I find f of all of these numbers. F of 0 is easy, it's negative 2. F of 2, 2 to the power 3 minus 9 times 2 to the power 2 plus 24 times 2 minus 2, that's 18. So f of 2 is 18. F of 4, 4 to the power 3 minus 9 times 4 square plus 24 times 4 minus 2, that's 14. And f of 5, 5 to the power 3 minus 9 times 5 square plus 24 times 5 minus 2, and that's 18. So what is the conclusion? Well, the absolute maximum is 18. I can write it f of 2, and it is also equal to f of 5, which is 18. That's the absolute maximum. And the absolute minimum is f of 0, which is negative 2. So these are the absolute maximum and the absolute minimum for the function. And also we found the local maximum and the local minimum. So you can notice that f of 4, f of 2, sorry, f of 2 is a local maximum, and at the same time, it's an absolute maximum. If you need any information, more information about these ideas or concepts, please study chapter 4 again. Okay, another question. So same steps. Let us find f prime of x, the derivative. This is product, so I'll use the product formula. Derivative of x is 1. Now the derivative of the square root is 1 over 2 times the square root times the derivative of 1 minus x, which is negative 1. So I have square root of 1 minus x over 2 square root of 1 minus x. To find the zeros of f prime and the critical numbers, I will add these two terms using addition of two fractions. So this is the denominator, and then 2 square root of 1 minus x times square root of 1 minus x minus x. So I have 2 minus 2x minus x. So this is minus 3x. So this is f prime. This is the first derivative. Now I can find the zeros of f prime. So to find the critical numbers, f prime equals to 0 when 2 minus 3x equals to 0. So when 3x equals to 2, or x is 2 over 3. So this is a critical number. And f prime does not exist when x is 1. So I have two critical numbers, 2 over 3. Of course, 1 belongs to the domain of f. You notice that the domain of f, or let us talk about negative 1 and 1 in this case. It belongs to this interval. If you want to find the domain of f, then 1 minus x should be greater than or equal to 0, 1 greater than or equal to x. So actually the domain of f is all the values x less than or equal to 1. So it's from negative infinity to 1, and 1 is in the domain of f. So it's a critical number. So I have two critical numbers. And the two critical numbers are 2 over 3 and 1. And these two critical numbers belong also to the interval negative 1 and 1. Okay, to find out whether uh, these two critical numbers, where we have local maximum or local minimum at them, I can find the second derivative, but the second derivative is not easy here. Okay, so I will use the first derivative test. And the first derivative test is to make this table. Okay, I have, I will work with negative 1 and 1 because this is the interval. So from negative 1 to 1, I have 2 over 3 in the middle somewhere, okay? And yeah, these are the three numbers, okay? So let us find the sign, test the signs of f prime. Well, this is f prime. If I put a number greater than 2 over 3, say 10, for example, then 2 minus 30 is negative. So f prime is negative here. While if I choose a number between negative 1 and 2 over 3, say 0, for example, it would be positive. So it's increasing here and decreasing here. And I have a local maximum at f of 2 over 3 would be a local maximum. Okay, what about the absolute maximum and the absolute minimum? I have negative 1 and 1, the endpoints of the interval, and I have 2 over 3. And now I need the function. Yeah, this is the function. Replace x by negative 1. 1 plus 1 is 2, so this is negative square root of 2. At 2 over 3, it is 2 over 3 times square root of 1 minus 2 over 3, that's 1 over 3. At 1, it is 1 minus 1, that's 0 times 1, 0. So this is the absolute minimum. Absolute minimum is negative square root of 2, which is f of negative 1. And the absolute maximum is 2 over 3 times 1 square root of 1 over 3, which is f of 2 over 3. So f of 2 over 3 is a local maximum, and at the same time, it is an absolute maximum. Same question, but with another function. Here to find f prime, I will use the quotient formula or the quotient rule. Derivative of the numerator is 3. Derivative of the denominator is 2x. I have to expand 3x squared. There is no common factor to take. Minus 6x squared minus 2x times minus 4 is 8x. And as usual, we do not expand the denominator. Well, I have negative 3x squared plus 8x plus 3. So this is f prime. Now I need to see whether I can factor this numerator. Let me take negative as a common factor. So I have 3x squared. It's easy or easier when I take negative as a common factor. It's easier to factor for me. So I have negative. Now let us try to factor this trinomial. I have 3x and x. If I put here negative 3 and here positive 1, then 3x times x is 3x squared. X minus 9x is negative 8. That's fine. So this is the factored form. So this is f prime in simplest form. And I can find the zeros of f prime. F prime is 0 when x is 3 and x is negative 1 over 3. And f prime does not exist, never, because x squared plus 1 is always, has no real zeros, always positive. Well, the interval is from negative 2 to 2. 3 does not belong to the interval. Okay, although it belongs to the domain. So we could have a local maximum or local minimum at 3, but he is asking only in this interval from negative 2 to 2. Well, f double prime, a lot of work, so I can test the signs and use the first derivative test. From negative 2 to 2, and I have negative 1 over 3 in the middle. Well, if I replace a number between negative 1 over 3 and 2, 0, for example, this is negative, this is positive, negative times negative is positive, and notice that the denominator is always positive. Between negative 2 and negative 1 over 3, say negative 1. Negative 1 minus 3, that's negative. negative 3 plus 1, that's negative, and this is also negative. Three negative signs multiplied by each other. So I'll get a negative sign. So here the function is decreasing, the function is increasing. So there is a local minimum at at negative 1 over 3. And the local minimum is f of negative 1 over 3. To find the absolute maximum and absolute minimum, as usual, I put the end points of the interval and all the critical numbers inside this interval. And I go to f of x and I replace x by negative 2. So negative 6 minus 4, that's negative 10. And negative 2 squared is 4 plus 1 is, that's 5. So actually f of negative 2 is negative 2. And f of negative 1 over 3, 3 times negative 1 over 3 is negative 1 minus 4. That's negative 5. And negative 1 over 3 squared is 1 over 9 plus 1, that's 10 over 9. So the answer is negative 9 over 2. And 6 minus 4 is 2. And 4 plus 1 is 5. So f of 2 is 2 over 5. Now that's the largest, so the absolute maximum is f of 2, which is 2 over 5. And the absolute minimum is negative 9 over 2 is less than negative 2. So it's f of negative 1 over 3, which is 9 over 2. So again, f of negative 1 over 3 here is local minimum and absolute minimum at the same time. Another example. Product rule. The derivative of e to the power negative x is e to the power negative x times the derivative of negative x, which is negative 1. Now I have x common factor, e to the power negative x is also common factor. So I have 2 here and here negative x. Okay. So this is f prime and it's equal to 0 at x equals to 0. E to the power negative x is never 0. Actually, this is 1 over e to the power x, and e to the power x is never 0, or x is 2. So I have two critical numbers. So these are the critical numbers. And f prime always exists because 1 over e to the power x is e to the power x is never 0. All right. So I can find f double prime here, but it's okay to use the first derivative test. 0, 2 are in the interval. All right, this is f prime. Choose a number between 2 and 3, 2.5. 2 minus 2.5 is negative, 2.5 here positive. This is always positive. So the sign here is negative. Choose a number between 0 and 2, 1. 2 minus 1 positive, positive, so this is positive. Negative half, this is positive, this is negative. So f here is decreasing, increasing, decreasing. And there is a local maximum. The local maximum is f of 2, and the local minimum is f of 0. To find the absolute maximum and minimum, I put all the critical numbers with the endpoints of the interval, and I find f of all of these numbers. Negative 1 squared is 1, e to the power negative 1, so it's e to the power 1. 0 times 1 is 0. 4, e to the power negative 2. 9, e to the power negative 3. Well, e is approximately 2.7. 4 times e to the power negative 2 is approximately 0.54. 9 times e to the power negative 3 is approximately 0.45. Okay, so the absolute minimum is f of negative 1, sorry, 0.45, f of 3, no, f of 0, because 0 is the smallest number here. And the absolute maximum is f of negative 1, which is e, because e is the largest one, 2.7. So f of 0 is a local minimum, and at the same time, it is an absolute minimum. Another type of questions about chapter 4, find the limit. When I replace x by 0, e to the power 0 is 1. 1 minus 1 is 0. Tan 0 is 0. So 0 over 0. So I can use L'Hopital's formula. The derivative of ex is ex. Derivative of negative 1 is 0. Derivative of tan x is secant square x. Now, secant 0 is 1 because cosine 0 is 1. And e to the power 0 is 1. So the answer is 1. That's the limit. If I replace x by 0, e to the power 0 is 1. E to the power 0 is also 1. 1 minus 1 is 0. 0 plus 1 is 1. Ln 1 is 0. So I have 0 over 0, and I can use L'Hopital's formula. Derivative of e to the power 2x is 2 times e to the power 2x. Derivative of e to the power negative 2x is e to the power negative 2x times negative 2. So this would be positive. Derivative of ln is 1 over x plus 1. Now, if I replace x by 0, e to the power 0 here is 2. E to the power 0 is 2, so I have 2 plus 2, which is 4. And if I replace x by 0 here, 1 over 1 is 1. So the answer is 4. If I replace x by negative infinity, negative infinity squared is infinity. Negative infinity cube is negative infinity times negative, so it would be a positive infinity. Infinity positive time positive infinity is infinity. Okay, infinity plus infinity is infinity. Times e to the power negative infinity, that's 0. Okay, so this is infinity times 0. Notice that if this is infinity and this is infinity, then the answer would be infinity. But 2 times negative infinity is negative infinity, and this e to the power negative infinity is 0. So what to do? I take one of these two below. So I choose to take e to the power 2x below. So it would be e to the power negative 2x. And now if I replace x by negative infinity, I will have infinity over infinity, because this would be negative infinity, infinity, e to the power infinity is infinity. So now I can use L'Hopital's rule. Derivative of x squared is 2x. Derivative of x cubed is 3x squared. Derivative of e to the power negative 2x is this one. If I replace x by negative infinity, this would be negative infinity. And this is negative infinity squared infinity. Minus 3 infinity means minus infinity. And minus infinity times plus minus infinity is negative infinity. Over e to the power negative infinity infinity. E to the power infinity is infinity times negative 2. That's negative infinity. So I have infinity over infinity again. So I can use L'Hopital's rule for the second time. Derivative of 2x is 2. Derivative of 3x squared is 6x. Here I have e to the power negative 2x times negative 2 times negative 2. This is 4. Okay, because negative 2 is just a constant. Now if I replace x by negative infinity, negative infinity would be infinity. Infinity plus 2, so I have infinity over e to the power infinity over infinity again. So again, I use L'Hopital's rule. Derivative of negative 6x is negative 6. 2 derivative 0. Derivative of e to the power negative 2x is e to the power negative 2x times negative 2, but there is a 4, so this is negative 8. Can cancel negative with negative. Now when I replace x with negative infinity, I'll have 6 over infinity, and that's 0, so the limit is 0. Replace x by 1 over 0, that's infinity. Len 1 is 0, so that's again another infinity. So I have infinity over infinity, minus infinity. And you have to check, by the way, because this is from 1 to the right. So if I replace x by 1.1, so actually the limit is infinity here, okay? Because the limit could be negative infinity or infinity when you divide something about 0. And here, len 1.1, that's actually len 1.1, that's 0. Okay, it would give you a positive number. Len 1.1 is a positive number, so again the limit is infinity. Okay, len 1 is 0, but len 1.1 is positive. So it is infinity minus infinity. You have to make sure that it's infinity minus infinity, not infinity plus infinity or negative infinity minus infinity, because the answer would be negative infinity or infinity in that case. What to do when I have infinity minus infinity, because this is the indeterminate form. I have to add, so x minus 1 times len x, and x times len x minus 1 times, so minus x and minus times minus plus 1. Now if I replace x by 1, len 1 is 0, minus 1 plus 1, that's 0. And 1 minus 1 is 0, len 1 is 0, so I have 0 over 0. And now we can use L'Hopital's rule. Product, derivative of x is 1. Derivative of len x is 1 over x. Derivative of 1 is 0. Product, derivative of x minus 1 is 1. Derivative of len x is 1 over x. This is 1. X times 1 over x is 1. So 1 minus 1 is 0, so I have len x here. And here I have len x plus x minus 1 over x. If I replace x by 1, len 1 is 0. Len 1 is 0. 1 minus 1, 0 over 1, that's 0. So 0 over 0. If you want, I can leave it like this, or I can multiply by x over x to get rid of this x. So I'll have x len x, and I'll have x len x plus x minus 1. Now again, if you replace x by 1, you will have 0 over 0. And I'll use L'Hopital's now. Product, derivative of x is 1. x times 1 over x is 1. Derivative of x ln x is ln x plus 1 as this, plus 1 minus derivative of 1 is 0. Replace x by 1 now. Ln 1 is 0 and I have 1 here. Ln 1 is 0 and I have 2 here. So the limit at the end is 1 over 2. If I replace x by pi over 2, tan 90 pi over 2 is sine 90 over cosine 90. And that's 1 over 0, which is infinity. Cosine pi over 2 is 0, so it's infinity to the power 0. One of the indeterminate powers, so I call y equals tan x to the power cosine x. I apply ln to both sides, and hence I can bring cosine x down and I have ln tan x. And now I'll find the limit of ln y. Limit of ln y. If you need more information, just see the videos about L'Hopital's rule. This would be limit of ln of cosine x times ln tan x. Cosine pi over 2 is 0, ln tan x is infinity, ln infinity is infinity, so 0 times infinity. I have to take one of these below. So cosine x, when I take it below, it's secant x, because secant is 1 over cosine. 1 over secant is cosine also. Now, this is infinity. Secant pi over 2 is infinity. So I have infinity over infinity, because cosine pi over 2 is 0, and 1 over 0 is infinity. So now I can use L'Hopital's rule. The derivative of ln tan x is 1 over tan x times derivative of tan, which is secant square x. Derivative of secant x is secant x tan x. Well, simplifying this, I have secant square. Tan will come here, multiplied, so it would be secant tan square, because I'll multiply by this tan. Now this will go with this, and I'll have secant over tan square. Let us simplify secant over tan square. Well, let me change by changing everything to sine and cosine. Secant is 1 over cosine, and tan square is sine square over cosine square, so cosine square will go up, and I can cancel cosine with cosine, and I'll have cosine over sine square. Now cosine pi over 2 is 0, while sine pi over 2 is 1. So the answer is 0. So ln y goes to 0. Then if I raise to the base e, so e ln y, which is y, will go to e to the power 0 or 1. So this limit is equal to 1. That's the answer. Well, I'll stop here and continue in another part.